I would like to welcome to the stage our next speaker. Now, we have, I think, Stuart Muckley from Code Wizards. So if he could take a step forward, he's going to be speaking about taking care of your back end, setting up the infrastructure. Stuart, can you hear me okay? I think you're muted at the moment, but you're online. Oh, I think you need to, in Zoom, you're muted in Zoom still. There we go.
There we go. Technical
How's
issues.
that, Stuart? Welcome. How are you doing?
I'm very good, thank you. You?
Good. Yeah, no, good. Thank you. Yeah, very well. I'm sad not to be in Helsinki, which is one of my favorite cities, but we're making it all work from our remote offices. So what I'm going to do is I'm going to fade into the background, give you the floor to give your talk about infrastructure. Folks watching this, if you have any questions for Stuart, please pop them in the Q&A. If you like, Stuart, you just carry on. Don't worry about those. I'll join you at the end and I'll pick those questions up if you like. So however you want to do it, I'll go over to you, Stuart Muckley. Thank you.
Awesome. Well, welcome to everyone that's here. It's slightly strange. This is my first virtual conference ever, so we're just going to have to work along with this. So the subject that we're talking about today is looking after your back end, and basically is a brief introduction to myself and who I am. So I've been in the games business for quite a long time. I started programming, believe it or not, 33 years ago, which is kind of terrifying to talk about when somebody gave me a ZX Spectrum to play with. I've worked on multiple games. My favorite one, if you're allowed to have a favorite, is still Titanfall 2. As a business, we're part of the company called Code Wizards, and we work across multiple games on game tech and esports tech. My favorite game is Bubble Bobble. We're members of Yuki, and you can see the other little things that are down there about Snap and table tennis, which is all true. I am extremely good against toddlers. So what we'll cover today. One of the things that I often find with indie developers is that they don't know what's out there and what's around. They tend to build things again and again and again. And so a lot of the chats that we have really around backends and what it can do for you and how to do and how to structure it. So we're going to cover a few things today, quite a high level, and then we can always dig down later in further sessions. So what is backend? Why is it important? Why does it work for you or doesn't work for you? What is live ops? You know, loads of people are talking about it, but what does it mean? How should you use it? Multiplayer. I often talk to people and they tell me that they'd like servers all around the world, and we have to speak to them and talk to them about cost and effort and all the rest that goes alongside it, and also how you scale that. Esports is the topic on everyone's lips at the moment, and it's great, but competitive gaming, really we need to work out the modes that work for you and your games, and then analytics is really how you can make your game better by actually understanding and making things evidence-led. Then we're just going to follow up with a brief recap, and then we'll just talk a wee bit about where we go next and have a Q&A session. It's only 20 minutes. Hopefully it's not too boring, and hopefully it's useful to all of you. So when I started in games a long time ago, it was on these things called cassettes. Most people these days haven't even seen them. Then we moved to floppy disks of varying sizes, and then we moved to CDs and then DVDs and Blu-rays. Awesome. In those days, you shipped a game, and when you shipped your game, you were virtually done. That was it. That's the way it finished. There was no major internet play. There was none of those things that were there. But now games are living. We play them for more. We play them for longer. People pick up games after a few years, and back catalogs are big. These days, releasing a game and just praying that everything will work is a really, really bad idea. So one of the functions of a backend is being able to change things, configure things, give different functions, and really tune it up as it goes along. So what is a backend? Well, it's everything behind the scenes, literally everything that's outside of your game client, normally connected via the internet, but parts of it could be running on one of your clients alongside, which is taking the place of it. So if you're running multiplayer, you may have game servers, you may be working peer-to-peer. Hopefully you're tracking your data in some way, whether that's a tool out there like Game Analytics, or you've built your own to find out bits of information that you need. Games these days have often got achievements, quests, trophies, badges, other things that are going alongside, clans, teams, and player information. So all of those things need to go somewhere, and they need to be tracked and managed. A lot of free-to-play games and other games as well will have some form of currency, and that currency could be XP, levels, mana, juju. some form of jewels, dollars, whatever else it may be. But also there's other content types. There's in-app purchases, there's general DLC, and there's new modes, new levels, and changes that we make over time as we tune that game up. It could be as simple as just changing the wording to make it easier for people to understand. Regionalizing is becoming more and more interesting in some games. So different markets and different territories have different needs, and they play games slightly differently. So some of the bigger players are now starting to use these facilities to regionalize their game to each individual market and really tune it up so it works for them. We have competitive elements, which, we can use the phrase esports if we wish, but really it's competitive elements that draw people in. And either that's that people can play collaboratively together or play competitively together, or maybe for events when they come back to this universe after this COVID-19 incident stops. Marketing is incredibly important. So especially for free-to-play games, we really want to pull people back into games and get them to play it and work as part of that community as well. So we've got that integration. And then last but not least, there's also comms that go on. So whether it's less likely to be video comms, but we'll often have text and audio moving. And those are the important things that you need to look at as well as part of your solution. So starting off with live ops. Right. Why do we need live ops? So when a game gets released, people either play it because it's fun and engaging, or they don't. If you're a free-to-play or any other sort of game, you either need to sell your game to make revenue, or you need people to play it and spend in that game if you're a free-to-play or a mixed mode game. So all that financial viability is based upon whether it's fun and engaging. So live ops allows you to tune things after you've gone live to try and make people happier and therefore make more revenue for you. It's really simple. So our friends at Fundamentally Games work a lot on the live ops side of managing live ops services. And so they've got a great list of things. So I'm not going to read it out for you because it's on the screen, but as a basics. So they talk about events and promotions, content, features, community management, and problem management. My opinion is that good live ops needs to be handled outside of the dev team. And we'll come to why in a minute, but this is one of the major issues that we find with a lot of games that are out there, especially those games that are running, are meant to be running for a long time and have a free-to-play aspect for them. Sorry, I think I've skipped one. So how to implement? Really, there's three main approaches. There's hybrids as well. So we've got traditional utilization of platforms such as AWS's GameSparks or PlayFab or Chili Connect or Nakama or one of the others that are out there, or creating your own full live ops functionality. And I'll get to what the difference between traditional and creating your own really is in a moment. Traditionally, the way that live ops have happened is that it kind of accretes and gets melded into the game as things go on. So a lot of things are developer-led, a lot of configurations developer-led, so it could be in config files or in the old days ini files. It could be actually baked into the code and then changed as things go on. But really what's happening here is that little rules and features and behaviors are kind of getting packed into the game as you develop it alongside. And the consequence of that is that every change requires a developer. Now, as you're developing the game, that's not a major problem because that's what you're doing. You're developing it and you're trying it and you're iterating and you're playing and it's all cool. However, once you've released the game, a lot of the people that we work with are actually stuck where their development team is continuing to do live ops instead of moving on to the next big thing. And that could be DLC or thinking about the next game or even just prototyping out what it is that they want to do next as their next game. And so it becomes really a barrier to getting things done. The next thing is it increases the code size. As code gets accreted, more and more things get patched in, people get bored, they patch more things in, so you end up with code upon code upon code. And lastly, and probably most crucially, it's nearly impossible for non-coders to understand the behaviors of the system. They can't look at the code, they can't read the code, they can't work out what's going on, so they can see behaviors that are occurring through the system, but they can't see the implications of changing things, nor how easy it is to change it as it goes out. To cater for that, off-the-shelf systems came about. So these are the things like PlayFab, GameSparks, Chili Connect that I mentioned earlier. So there's quite a few of them available, and you buy them as a service, paying monthly for the amount of users that you've got, so they scale with you. There's a lot of advantages to off-the-shelf, especially for smaller studios. So it's already there, it already runs. People have already tested this and battle hardened it, so you know it's going to work and you know what the limitations are as well as the benefits. As you're building your game and connecting into it, you can bring a lot of features online really quickly. So for example, if you wanted to put leaderboards in your game and see how that played, you could do that without very much code at all, instead of having to code an entire leaderboard system. The downsides, of course, are that it only scales to a certain level. So if you're building the next AAA that's out there, then I'd suggest that you probably need a custom platform. But for 99% of us building games, it's more than good enough. The other great thing about off-the-shelf is availability of people. So a lot of community managers, live ops staff, support staff will have access and will have played and used in production the live ops systems themselves. So whether it's GameSparks, PlayFab, Chili Connect, you can usually find somebody who knows what they're doing. And really that's ideal because it prevents you as developers having to get involved all the time. However, you of course need some level of coding. They're not magic. It needs to be integrated and it needs to be managed. So depending on which one it is and how you do it, you will need non-technical staff to play with it, but you will need technical staff to integrate it. So in contrast to both those is a conscious build your own. So for some live ops functions, you need scalability that nobody else has got, or you need features that nobody else has got. For example, ladders off the shelf for 1 million or 2 million users, or some other requirement that you have. It's going to cost you more than using an off the shelf, and it's going to be slower than going off the shelf. But one critical thing that people don't realize is that when you build your own systems from scratch, they will have more bugs than off the shelf. Is that a major issue because you can fix them? Well, it depends on your team really and how much time you can devote to it. And it's inevitable that a bug will be found right at the last minute before you ship your game, or just at the critical point that a journalist is reviewing your game. So you just need to bear those things in mind. But you get something that works exactly for you. And there's very successful implementations out there which have allowed for global variations and localizing it, and also design that so that different live ops teams can manage and run these things, even federated across the globe for the different regions, so you can have a different flavor and feel to the game in those regions too. Now, the first caveat on this is that we're going to talk about multiplayer at really high levels. And the reason why I'm going to do this is to try and counter a lot of the questions that we get asked every Gamescom. And hopefully it's useful. Please let me know if it's not. There's a lot of ways to create multiplayer games, but in reality, there's two different ways of thinking about it at a high level. So one is non-authoritative and the other is authoritative. In both methods, what we're really doing is taking information from our clients and throwing it up to somewhere else, and everyone else is reading that information and making sure that you're all synchronized. That's how multiplayer works. However, underneath the covers, it makes a lot of a difference. The one thing that I will say, which I see a lot, especially with indies, is that if you don't have server experience and you don't have engineering experience, you're a games house, then please find some help, whether that's an independent who can help you or just working through things. The amount of games that we've worked with where the server keeps crashing all the time, it's kind of scary. The fact that it works in your local dev environment doesn't mean that it's good enough to go out into production. So test, test, test. Ensure that your mean time to failure is really high. So in a non-authoritative world, it's really simple. So whether it's peer-to-peer or we're using the server, everyone sends their information and everyone gets their information back. It's really easy to do because there are lots and lots of off-the-shelf libraries that you can use. You know, if you're a Unity fan, then Photon will work pretty much within seconds as soon as you get it in. It's great, it's really easy, and for a lot of products, it will work absolutely perfectly. However, one of the things, and this is pertinent based on the previous talk about cheating, is that as esports is maturing and as betting is occurring on some of these esports, one of the things that's really interesting about it is making servers authoritative so we can ensure that we've got an authoritative view of the universe. But these things are incredibly cheap to run, especially with peer-to-peer. You won't need any special servers. You don't need to globally scale. You don't need to do anything. Some very successful, even AA and AAA games still use this system. So when it comes to authoritative, what we really mean is that there is something that is in control of everything. The server is the boss. It understands everything that's going on. It has a single true version of the universe, and everybody has to listen to it. So the question becomes, well, why doesn't everybody do that? And the answer is, well, firstly, we need to run the universe somewhere else on a server, and we need something to provide that authoritative version of the universe and send it down. It's more complex because we've got all that going on there. It's a lot more expensive because typically we need to run servers on it, and we need to run those servers globally, and we need to scale those servers globally over time to account for our player demands. But on the plus side, it's a lot harder to cheat and abuse, and that's good for two reasons. So the first is just from player satisfaction. Players don't like cheating. None of us like to be rinsed or beaten in a game by somebody who's obviously using a cheat. The second thing is that for esports, it makes the system a lot fairer, and you can trust the results from it a lot more. So it's more of a fun game, it's easier to understand, and it's a better viewing spectacle for those watching too. So scaling is something I've got a lot of experience about, sadly. So when you have your own game servers, you're going to have to handle the load. So the typical conversation, especially with developers just starting on multiplayer games, is they talk about high demand and what happens if things go crazy. And it's great, and you should think about that, and you should manage it. However, I'd recommend worrying about low demand just as much. If you build a static suite of hundreds, if not thousands of servers globally, and nobody plays it for 2 weeks, then you've got a lot of a cost base just sat there waiting. Especially with a game where you release it and it's not quite right, and you just need enough time to fix it and get the next version out there. And that could be when you release the game, or when you release a DLC that's slightly broken, or whatever else it may be. The whole thing about scaling is that you can manage things over time across regions. And the second thing here is that you need to consider patches and versioning. So again, it's something that most people never really account for at that point, but once you've released your game, you'll be releasing other versions. Things will change. You need to make sure that you can allow for that. If you're talking about the consoles, you'll normally release in smaller batches in different territories at different times. So you need to make allowance for that as well. So if your client can't release alongside a server release, then you need to manage that. And that's what a big part of this is. So how do we scale? Well, we could create our own. We could provision fixed fleets, i.e. we could go to somebody like servers.com, ask them for their data centers across the globe, build a bunch of servers and put things on. So, or we could use a service, or we could use a mix of those. And so what we're going to talk about here is just how to do that. So when you create your own, you've got a lot of work to do. So you've got to instrument the servers, you've got to bring them up. You've got to have sentinels which run on those servers to check that your game servers are actually running at any one point and are doing what they need to do. You've got to check that there's no memory leaks or other issues that are going on. They've got to validate that the DLC is correctly installed. So there's a lot of work there. So it's an option, but building a scaler, unless you really, really need to, I'd advise not doing. You could provision a fixed fleet, and for some games this works fantastically well. So if you've got a low bandwidth game, particularly the asynchronous games, if you're building a war game, fixed fleets are a fantastic value for money because you know exactly what you're going to pay for and you can financially plan for that in advance. That bare metal is really easy to hire around the globe. It's pretty easy to get near to the clients, and in some regions, it's the only way to go. For services, I've just put 3 of them down there. There are more, of course. So GameLift will scale across AWS data centers. And you can also use Fleet IQ, which is their system for scaling outside of it as well. Works really well. It's really simple to do. You can tie it in. Unity's multiplay works across bare metal, AWS, Azure, Google, and some others. So if you need to go across cloud, across globe, then multiplay is pretty much your best option. And the new contender on the block is GameEye, who have taken a lot of the learning from the multiplay system and are moving forwards. And the last part is hybrid, which is run a base, i.e. provision a fixed fleet, and then you could use something like AWS GameLift on top if you needed to. As I mentioned, esports is one of those hype words, so we need to be careful about how we look at it and how we deal with it. So realistically, we need to ignore technology. So what we need to work out first is, what is this game trying to achieve? How is it trying to achieve it? So is esports a mechanism to acquire new customers? Is it a way of getting people in? Is it a way of retaining those customers, or making them play more? And you've really got to work that against your monetization model. So the big thing really for me is that not all esports is a single elimination bracket. Single elimination brackets are awesome. If you go to an event and watch it, they're really exciting to watch and it's great. But in reality, your game probably needs something different. So the second thing is that your game's esports competitive playing needs to work in different ways at different times. So for example, if we have a single elimination tournament at an event where we're playing the game, we want to use a mode called slaughter. So we essentially want the best player to play the worst player, and the best and second best player to be at opposite ends of the bracket and fight their way to the end. And that will give us some of the most exciting matches that are there. If, however, we're playing a bring your own computer event where we want a lot of people to play and have some fun, we may want double elimination so everyone gets 2 goes at it. And we probably want like-minded people or like-skilled people to play each other, so you get more of a fun game and it's more engaging. So you need to think about those things. Lastly, nobody wants to go to an event and watch a 25-hour ladder. So ladders are awesome. They work great for retention, but at an event, you need to think about it, how it is you do it. And the last part, which I think is going to be emerging massively over the next few years, is we need to give tournament operators the best chance of success. We need to allow APIs or data feeds in there. So if you can do that and make those APIs available, I think your game will stand a much better chance of being used within various esports events. Analytics. The big thing about analytics is everyone talks about it and very few people do it. The 2 things to really consider are, is your data understandable? Can anybody but the development team understand it and use it? And is it actionable? So by getting this data, is there anything I can do using this data to make a material difference to the outcomes? So always bear those 2 things in mind when you're working your way through. For storing your data, another interesting thing is I hear a lot, well, we'll just make a data lake. We'll just put everything in the data lake, it'll all be cool. Well, again, we need to understand the noise to signal ratio here and what it is you're trying to do. So if you've got a huge data analytics team that's really competent, awesome. Go for a data lake, store as much as you can. You can mine the data down to the nth degree. Otherwise, try and work out what it is that you're really trying to ask of the data and how you're going to ask the data those questions. Now, you can't answer everything, so you've always got to pack a bit around the outside, but think about those things carefully before you start doing it. And the last thing is keep your data pruned. So unless you've got a really long living game, which is going to last for years and years, any data from 3 years ago is largely just noise. Your game has evolved since then. Create summaries if you need it, but in the main, it won't be that useful to you. So don't think you're holding on to it as the crown jewels forever. When it comes to viewing data, there are lots and lots of tools that are out there. So some of our most successful clients build dashboards into their live ops platform so everyone can get access to that data really quickly. If you are going to do that, make sure that the data is really clean, really simple, and it maps to what your goals are. So my example there is, if you want 1 million players a day, show that on screen and show how well you're doing. Otherwise, it's just a number. And if you are using off-the-shelf tech, Game Analytics and Co, they're awesome. They've got loads of pre-baked reports in there. Use it. That is the knowledge that other people are giving you. Use it as much as you can. When it comes to the next level, which is data exploration, this is where your teams, your community managers and various other teams will want to look at the data and use it. These days, there are a lot of ways that you can do that. So if you've got a data lake, Athena will sit over the top really nicely. You can hook tools such as Power BI or even Excel, if your staff really know Excel really well, into there, and you can work out what's going on. But the beware is, if the nouns within the data are not well understood, then people can very quickly get the wrong conclusion and follow that up. So you've really got to be careful. And for data scientists, our method really is we give them what we call chainsaw access. So we get them as near to the data as they possibly can. And if they need to do weird and wonderful queries to answer a hypothesis or to look for other leads, that's cool. So a quick recap, because I think I'm running out of time and I've been talking for quite a long time. So for most games, I recommend using a live ops platform if you can, but make sure your non-techies can access it. For esports, ignore the tech, match the tournament types to your game. If you don't know about esports or how to work with it, there are a lot of people you can reach out to out there who run esports and will give you all the information you need. When it comes to multiplayer, don't always think that you need authoritative unless you really, really do. Make your mean time to failure as large as you possibly can. Make your game servers super efficient if you can, and support versioning. Lastly, don't run voice over your data channels. It's a really bad idea. For scaling, plan to scale down as well as up. Make sure financially you can actually afford what it is you want to do by working out your monthly costs and things go up, and keep a close eye on it. So if you are scaling up, make sure that your income is scaling up at the same rate. Otherwise, it's just a financial liability and your game will go under. And for analytics, make it super simple if you can. Cool. So I hope you like it. As I said, my name's Stuart Muckley. I'll be happy to answer your questions now, providing we got time, Dave.
We're tell you what, we've got a couple of questions here. Let's grab them and see if we can get there. We've only really got a couple of minutes, but we started a couple of minutes late, so that's fine. Let's go there. Stuart, that was great, really interesting. You covered a lot of ground there, and also you had right from the start. I wanted to say, oh my god, I've been playing games since the ZX Spectrum. I want to buy this guy a beer and find out about the what he worked on there. Also, by the way, Titanfall 2 is a great game. Love that. So let's dive into these questions here. Let's see if we can sort of reply to these succinctly, and then in the time we've got left. So you can see there in the window, an anonymous attendee asks, what do you think is the best solution for indie developers who don't have funds yet to pay for an external company for live ops, but also would suffer from being stuck on a release game? What do you think? What's the indie solution, Stuart?
There are options that are out there. So things like Nakama have got a free version, so you can use that. The other thing that you can do is reach out to the AWS staff or the Microsoft staff or the Unity guys. A lot of the time they're happy to help, and they're happy to pull people in and give you access to things that normally you wouldn't be able to afford to do. So yeah, just speak to people.
That's great. That's great advice. And let's do this last question here then from another anonymous attendee. There is a myth around that it is impossible for a small team, let's say less than 10 people, to create a good multiplayer game. I have seen it proven wrong a few times, but why do you think this myth exists?
From my background, I think it's the myth of the ultra graphics. It's the same idea as, the snobbery between AAA and indies. So there are some absolutely fantastic one-person indie games that are out there that are amazing. Do they have AAA graphics? No. Do they have ray trace shadows? No. Does it matter? No. My favorite game of all time is still Bubble Bobble. That it's an ancient game. It's just the absolute, perfection of gameplay for me, at least. So yes, you can build an excellent multiplayer game, but it's all about the game mechanics, and it's all about how you interact and play. What I would say for a 10-person team, though, is make sure that you understand what you're signing up for, because on a 10-person team working 24-hour shifts 365 days a year, that's not a lot of people to go around and take holidays when you need to support it.
Very true. Look, Stuart Muckley, thank you very much for your time. Great presentation. What I will say to people is that if you do want to ask any more questions of Stuart, maybe they can find you on Discord or the Meet to Match server, or maybe they can contact you. So thank you very much. Round of applause for Stuart. Hopefully we'll get a chance to catch up at another live event soon.